Good morning everyone, my name is Rashmi. I am here to explain you a topic of chemical bonding. Now first of all, what is a chemical bonding? When the two different elements or similar element approaches each other, for example, an electron deficient element combines with an electron rich element, we know that metals loses electron and non-metals gains electron. When a metal and a non-metal reacts, it leads to the formation of a chemical bond. So exactly we want to know what exactly a chemical bond, that is when electron deficient or electron rich species combine, they lead to the formation of chemical bond, right? But why they are doing so? That the reason is to get the stability, because and you must know that the stability is inversely proportional to energy. We know that when the two elements are combining, there are force of repulsion and attraction between the nucleus and the outermost electron, right? So the net force would be the less energy, which leads to the more stability while the formation of a bond. Now there are different types of bond. There are different types of bond. For example, ionic bond, covalent bond, and coordinate covalent bond. Ionic bond exists between metal and metal. Covalent bond exists between the non-metal and non-metal. And this is having both their character, ionic as well as covalent character. On what criteria they are based or categorized? Fine. So it is electronegativity difference. If the electronegativity difference is less than 1.7, it would be regarded as a ionic bond. If electronegativity difference is more than 1.7, it would be 1. That would be a covalent bond. But if the electronegative difference is equal to 1.7, that would be a coordinate bond, right? That means it is having both ionic as well as covalent character. How much percent of what character is there, that would be considered by the valence rule. We can calculate. We will discuss later. Now we are coming to the different theories which are discussed in the chemical bonding. Now first is your VBT, valence bond theory. Yeah, it is valence bond theory. It says while combining only valence electrons involved, valence bond theory says it exactly told us about the different shapes of the orbital. Like there are, what are orbitals? Orbitals are like in which the possibility of finding electrons is more. For example, S, P, D, F, so on. So what is the shape of S? Shape of S is spherical, right? Shape of P is, it is having dumbbell shape. And it is possible, it is non-directional, S is non-directional, but P orbital is directional. P orbital, what are the different orientations? It can lie on X plane, it can lie on Y plane, and it can lie on Z plane. Fine. So these are the different orientations, Px, Py and Pz orientations of. Now what is the shape of D orbital? Now you must know that D orbital has the shape of double, right? So there are different orbitals of D, that is dxy, dyz, dzx, dx square minus y square, and dz square. This dz square appears to be the shape of baby Suda, which we know. There are 5 orbitals. There are 3 orbitals in P, 1 orbital in S, and P, 5 orbitals in D. So what would be the shape? I am explaining one, like dxy. So one lobe would be on X and one lobe would be on Y. X y, that would be dxy. Fine. And similar with dzx, now the lobes would be on either x and z. Fine. Now baby, so the shape would be like this, only a single lobe, and dx square minus y square as well. Now this theory gave us the shapes of orbitals and how the overlapping takes place. Fine. Now according to VBT, different orbitals, how do they overlap? So let's discuss that. Now, when a s orbital combines with a s orbital, that gives the ss overlap, right? And it leads to the formation of sigma bond. So according to VBT, the two types of bonds are either sigma or pi. Fine. So one s and one s bond gives us the ss overlap, and the ss overlap leads to the formation of a sigma bond. Right? Now let's talk about the p, or different possibility of s and p. So second is when a s orbital combines with the p orbital. So it would be like, there are two possibilities. If they are combining axially or end to end or head to head, so there is possibility of making a bond, that would be a sigma bond. But if it is combining laterally, so there will be not a bond formation, there would be a no bond formation. Now third possibility we are discussing is when a pp orbital is overlapping. When one p and one p orbital will overlap, so what kind of bond is formed? So we have seen ss orbital sigma bond, sp orbital sigma bond. Now pp orbital, what would be happen? Now when one p orbital is combining with one p orbital, so if they are combining axially, so what would be the bond formation? There will be a sigma bond formation. But if they are combining laterally, the second possibility of it is they are combining laterally, so there would be a formation of a pi. Fine. So when the p orbitals are combining laterally, then it leads to the pi bond. So what we have understood till now is, according to VBT, two types of bond are there, sigma and pi. Sigma formed bond is formed by the head-to-head overlap, while the sigma and pi bond is formed by the lateral overlap. Now, how can we discuss? How we will see? When there is end-to-end overlap, that would be a sigma bond, and when there is sidewise overlap, that would be a pi bond. Now let's discuss about our next theory, that is hybridization. So hybridization is a little bit modification of VBT. In this hybridization, we will discuss only about the covalent bond. We understood that elements are making a bond, and why they are making bond possibly. What is the structure exactly? In what orientation, what angle they are making, and in space how they exist. For that questions, we needed more complex theories, that would be hybridization, right? Hybridization, molecular orbital theory, whisper theory. Right? So the next one was hybridization. In hybridization, let's discuss hybridization. That means a hybrid. Hybrid means mixing. mixing of atomic orbitals, right? And it leads to the formation of your new hybrid orbital, which are equal in the energies, equal shapes. Now let's see, for example, an atomic orbital of S and atomic orbital of P. One atomic orbital S, one atomic P is combining. What would happen? One S and one P. They will give 2sp hybrid orbital. Yeah, 2sp hybrid orbital. Equal number of atomic orbital. The number of atomic orbitals would be equal to number of hybrid orbitals. So what is the shape of S? You remember it is spherical. What is the shape of P? It is dumbbell. So what would be the shape of SP? So one lobe will be bigger and another lobe will be smaller. So how we will draw it? Like this. Fine. This would be our 1sp hybrid orbital. So but there are 2 in number. So 2 hybrid orbitals. And on combining, what we will get? On combining one sp orbital and another sp orbital, they are combining, making an angle of 180 degree, and the shape will be linear and the hybridization will be sp hybridization. Now let's see about the sp2 hybridization. So first cases are sp hybridization and another is our sp2 hybridization. In sp2 hybridization, 1s and 2p orbital combines to give 3sp. That would be sp, that would be sp2 hybridization. So there are 3 sp orbital combining, which would lead to the formation of a new geometry or the shape that would be counted 1 sp orbital, 2 sp orbital and 3 sp. Fine. So a little bit incorrect. I will be making again. 1, 2 and 3. So angle would be 120 degree and it would be trigonal plane. So the same way we have understood sp3 hybridization.